Embedded World 2025. I'm here at the MIPS booth. Now, MIPS announced last year that they were going with the RISC-V architecture, and Sean's going to walk us through one of the tool for using the architecture and working with MIPS, which is Atlas. So, what are we showing today?
Yeah, so Atlas Explorer, as we've worked with our customers, a really important part of that is modeling and simulation, right? So this is part of our strategy for shifting left your development cycle, getting interaction with our core earlier, way before RTL, way before silicon ever is here. So Atlas Explorer is actually a plugin built into VS Code, so that it's intended to be very environment agnostic. So you can actually import your project directly into VS Code and then download our extension. And then you can run your code and get a performance performance report sent back to you, and actually get some really interesting performance data from this. And actually, what this is showing is our motor control demo. So as part of our new product, M8500, which is a microcontroller product, one of our very key application areas is motor control. And so this is actually a simulation running on our M8500 simulator, where we give it a target speed in this green line, and you can see that the control loop is actually attaining that target speed and spinning the motor and actually controlling the phase currents to control the motor. And we can actually take this model, and this is what we've done, and feed that into Atlas Explorer to actually find out how fast it's running. Because one of the key portions of real-time control is understanding how quick that real-time control loop is actually taking. And so this is a combination of our application focus with motor control, as well as giving our performance-aware tools and cycle-approximate tools to our customers earlier so they can benchmark their applications and optimize their applications earlier.
Now, one of the key things of the RISC-V architecture is being able to do custom instruction sets.
That's right.
So how do I use the Atlas Explorer to help determine if I should be using custom instructions?
Yeah, that's a very good question. So part of the Atlas Explorer tool actually gives you a way to highlight the key portion of your code where you're wanting to optimize the most. And so you can give a start and end tag to your key portion of code that may be causing you the most trouble. And then you can actually see just that portion of code instead of seeing the entire code flow. And then you can use a custom instruction in that code or not, and then run the two runs back to back and see a performance improvement between the two. Now, I'll also very quickly say part of our custom instruction strategy with M8500 specifically is that we are actually, as part of our focus on application motor control, real-time control, is actually we're going to be providing some of those instructions and execution units in order to accelerate motor control specifically. So we're going to actually have some specific examples that show, for example, a field-oriented control loop with and without that instruction and that performance improvement between the two.
So I don't have to develop the custom instruction myself for that application. MIPS has already done that work.
That's right.
And that's my choice if I want to use it or not.
That's right.
Well, and that's been one of the limitations. Nobody, it's a feature of RISC-V, but nobody seems to want to use it.
That's right. Yeah, and we found that same conclusion by talking to some of our customers. And so we've kind of, our conclusion was, we understand these applications, and that's part of the value that we think MIPS brings is understanding the system, the application focus. And so we're going to go in and say, hey, this particular algorithm can benefit generically from acceleration here. And we developed that instruction, but also those execution units in the pipeline itself.
And this is the new MIPS. So this isn't just selling you IP and providing you a tool. You guys will do as much of the engineering work all the way up to the final chip.
That's right. Yes.
That the customer wants.
Yeah, that's right. And that's part of our announcement as we are moving, towards physical AI is, beyond IP, we're building on top of our IP, building out subsystems and even up to reference silicon. Because again, as part of where we feel like we provide the most value, beyond just IP and real-time control. Turns out that goes beyond just the CPU. In order to give the full benefits of the system, you have to understand the full end-to-end latency. That ends up meaning the subsystem, and that ends up meaning the silicon itself.
Perfect. Thank you, Sean.
Thanks for the time.